Okay, hello, this is Radoshi. I'm recording a video series with Leetcode questions to help you whether you're preparing for internships, new grad, switching between jobs, whatever it may be. This is foundation that we're building, and so it has to be very strong and very solid. And the question that we're tackling today is a very classic sort of tree problem, which is level order traversal. Okay, so for level order traversal, this is sort of the idea, right? So I'm going to get rid of all of this, right? So basically, you want to traverse a binary tree in level order traversal. Very simple, right? So the way that you do this, so let's say if I give you a random tree, so I give you something like this: 3, 4, 5, 6. Okay, so level order traversal just means that I'm going to go level by level in this tree. Okay, so what does that mean? That means 1 is a level, 2, 3 is a level, 4, 5, 6 is a level. Okay, so with this, sort of the very intuitive sort of approach that you can think about is like, okay, you know what, I'm gonna have some sort of a data structure. So I have the 1, for example. I can, let's say I have the 1, I can pop this 1 and then I can put its children, and then I can, have like some sort of a visited, you know, list, for example, and I can put this 1. Then I can go to the 2, I can remove this, and then I can put it into visited, and then I can append the children of 2, which is 4 and the 5, and so on, right? So with this, you probably noticed something that I did here, which is every time I was popping from the very beginning, right? From the very beginning of this data structure, which looks like a list here, I was popping from the start. So this will already tell you that, hey, what we're using here is a queue. Why do we need to use a queue? Because it's first in, first out, right? It's not depth first search, okay? This is level order traversal. We're going level by level. So you can already understand that this is going to be a queue because we're going to pop from the very beginning every time, right? So that kind of makes sense a little bit. But then so when you do this code, because we were just doing this a little bit earlier just from intuitive approach, and a lot of mistakes can happen, right? Because with this you can have a misconception that, oh, I'm going to go to my node and I'm going to take both the children. Okay, I'm going to pop it, I'm going to go here, take the children, and that's going to be the level, and then go to the 3, take the children, that's going to be the level. But it's actually not true, right? The distinction here is that we're not grouping by parent. Okay, we're not grouping by parent, but we are grouping by level. Okay, so mistake that you made earlier on was that you said, okay, this is going to be my code. I'm going to have a queue, and I'm going to have a root at the very beginning, and then while that queue is not empty, I'm basically going to so I'm going to say queue.pop at 0. So I'm going to pop the first element, and then I'm going to check if so we're going to call this n, for example, and then I'm going to check if n dot left exists, then push. If n dot right exists, then push, right? And then you were even thinking about like grouping it together some sort of way, and then sort of combining it. So the reason why this doesn't work is because basically you don't want to go to just one route and then like append the children and then get it done with, right? Because what would happen in this case if you did this sort of algorithm is that basically you would just go here and you would say, okay, pop the 1 out, put the 2, put the 3, and then push the 4 and the 5, and then that would be the level. But then you would ignore the 6, right? That would never get appended. This would form a separate level where you would append sort of the 6 after figuring out that it's a child of 3. So we don't want to do all of this, right? So basically, very classic sort of intuitive approach of what we want to do is that we want to figure out, right? We want to figure out, hey, because I'm going level by level, how long is the length of each level? Okay, that is the very classic sort of intuitive approach. So if I look at, the same tree, for example, and then I say, Okay, so if I look at the same tree, for example, I want to know, hey, at level 1, how many times do I need to traverse? Okay, so at level 1, how many times do I need to go? At level 2, how long, how far do I need to go? At level 3, how many times do I need to loop? And how do you know that? Right? How do you know how far you want to go? It's gonna be literally the length of your queue, right? If at every level you're going and you're appending the children, right? So for example, when I go to the 1 and I say, oh, you know what, 1 has the things that are coming, the level that is next to it, 1 has 2 and 1 has 3. Oh, that's going to make up my level, right? So this is basically level 2. So how long do I need to loop for level 2? It's just going to be the length of this queue, right? So that gives you an idea that, okay, you know what, basically what I want to do is that, forgetting everything that's happening before, every time I just want to loop through. So I want to say for I in range of, the length of, so you can say that level size is going to be the length of your queue, and then basically that's how many times I want to loop, right? Because if you do this, then you get rid of the edge case that, oh, like, because in this case, if you didn't do something like this, you wouldn't know how many nodes are actually in your level. You would just stop after you found the children of the first parent, right? So you don't want to do that. So basically, you want to loop through the entire level. So you want to keep track of how long is my level, that's how many times you're looping. And what do you want to do at every time you are looping through this level? So for example, let's say for the 2 and the 3, what do I want to do? At every stage you want to pop, right? So when you're traversing, so your idea should be this, that when I'm iterating, I want to pop myself, right? The first thing, so when you go to the 2 here, I want to pop myself, right? I want to put into visited because, hey, I already traversed it, right? And then I want to actually be mindful about the next steps, like what comes after it. So then I want to check children and append. That's basically what I'm doing, right? Very simple, very clean. And so now let's actually go into the code, and then I can show you sort of some common mistakes. Okay, so you know that you're gonna have a queue with just the root, right? And then you can say like, oh, I'm gonna have visited, right? And then you can say, oh, while this queue is not empty, keep going. And then we said, oh, we're gonna keep track of the length of our queue, right? Yeah. So you can say, okay, I'm gonna loop now for I in range of length, or I can just say level size basically, right? And then every time I loop, what do I want to do? I want to pop myself, right? So I want to say, okay, you know what, let's call it node, and I'm gonna say q.pop of 0. So I'm going to do that, right? So I'm going to pop this element at the 0, and then you can say, oh, let me just put myself into, let me just put the value, because we want to deal with the values, right? Let me just put that into visited, and then I'm going to check for the children. So I'm going to say, okay, does node.left exist? Yeah. Then you can just append this into the queue. And then the same thing for the right child. Now I don't want to put this into visited, right? So you might say, oh, why don't you just literally, first of all, why are you adding the node, right? The reason why I'm adding the node and not the value is because the next time I traverse, I want to be able to sort of record myself and then go to its children, right? So if I just put the value, for example, if I just put the 9, then it's just going to be an integer, right? And then the reason I'm not sort of adding it into visited is because there's no point of doing that, right? I need to go level by level. So right now, so basically the way that you can think about this is that you break it down into steps. So right now all I'm doing is that I pop myself record visited, and then what I'm doing is that I want to record children for next level. So now this is not my job to put it into visited. I'm just going to put it into the queue so that it gets recorded, right? So that's the idea. So now you can say, oh, this seems fine, let me just return visited. But you can notice that they're actually grouped together. So every level is grouped together, not just the children. So this can seem like, oh, it's just probably the children of the parent. No, all the level nodes are basically grouped together, right? So this is very easy. So you can just understand that, okay, so that means that I cannot actually do this thing. I cannot just like put it into visited every time, right? So this is why you're going to have an inner list, very simple, and then you can just say, oh, I'm going to put this list over there, and then once I'm done looping, so let's say that my length of my level is 5, right? So then I've looped 5 times. So what is that telling you? It means a list now has all of these 5 nodes that I had in my level. So what can I do? I can push now these nodes into my visited. Okay, so that's basically the main idea. And then at the end you want to return visited. Okay, and then obviously yeah, so that's basically kind of just the intuitive idea. And a mistake before was kind of like not sort of going level by level, but if it's level order traversal, you cannot group by parents, like you have to do it this way, right? So let's error check a little bit. So you start with the queue, you have your visited, you record the level, you have the list, and then you're looping every time, right? You pop the element, and then you put the element into the list, and I'm putting the val. Yes, I'm checking. Okay, so let's see if I made so this is an edge case that you cannot ever forget, which is if root is none, right? So if the root is none, then you want to return empty. So this is just sort of one of those edge cases to be careful of. Okay, so now this works perfectly, but there is sort of an issue with the time complexity. Why? Because right here, right? So what happens when I pop something at the zeroth element, right? So let's say if I have 1, 2, 3, 4, right, and I pop something at the 0th element. So obviously I'm going to pop it, but then it's the shifting of the elements that actually takes O of n time. So because of this, there is like something you want to use here. So this is very simple. It's like, I think it's like from collections, import Q, import DQ, I think, right? And then, yeah, so let me check the syntax. I think it's like Q, how to use DQ yeah, so I think I can just initialize it. So I can just say DQ with the root, and then it takes an iterable, I'm pretty sure, and then I think it's like dot Q dot pop left, I'm pretty sure. How to use pop left. Oh, I don't think I give it anything. Yeah, so you see now the time complexity improves. This is very simple, like it's kind of, I almost memorized it, but yeah, so from collections you import this, and then that's just like that makes a runtime. So what is a runtime? Let's see. Oh, actually it's O of 1 time. Okay, because when you pop it, it is O of 1 time. But yeah, so that is basically level order traversal, and there's going to be more questions that I do with level order, pre-order, in order. So yes, I hope this was clear and helpful.